working in Department of ISC, Maharaja Institute of Technology, Mysore. So today I am going to handle the lab Computer Networks Laboratory. For the fifth semester, the subject code is 18CSL57. So the basic to the Computer Networks Laboratory. The things to be known, what you are supposed to learn with respect to this particular networks laboratory. So very previously we know the many of our basic concepts till now. That is we have come up by the OSI layers. With respect to that, we also learned the required layers functionalities and its advantages and where to apply and how to apply. So ongoing process of your computer networks laboratory, there are part A and part B. So your part A is all about the simulation. So in the simulation concepts, very first you should know what is simulation. It is a process of learning something by doing. That is, we are going to analyze, we are going to develop and we are going to test it. So something we know we need to form into a particular module. So well, in the part A we have the 6 programs. So we are going to deal with this particular concept of the simulations. So very first is all about the point-to-point network. So in your basic towards your network concepts, already have learned the different types of transmission modes. With respect to that, you also have learned the network topology. So likewise, on basis of that particular concepts, what we are going to try is, we need to find the simulation concept, how to deal with the network concepts. So accordingly, what happens is, all we are going to deal is the network laboratory with the simulation concepts. If we are going to tell regarding the simulation, in the previous syllabus, we used to deal with the NC2NS, where it was the basic, where directly there was a tool used and where the drop and drag concept were used. And according the simulation was run and we used to see the result. But now it's the time to be updated. So, well to that, in this particular laboratory, you are going to learn the NS2 that is the Network Simulator 2. So where this is the combination of your C++ as well as the object-oriented concepts of tool command language. So in that, very first you are going to learn the program point-to-point networks, and you are going to find how the data packets will be dropped and how the data packets will be received. So on continuation to that, the second program, that is all about the ping message over the network topology. So that with the help of the simulation set commands, we are going to learn how to ping a message over the network topology. On the third one, that is all you are going to learn regarding the Ethernet LAN and how does the multiple traffic nodes will be set up. And accordingly, that will be followed by the wireless LAN in the fourth program, where you are going to analyze the transmission of packets with the help of the congestion windows. And the fifth one is all about the performance of GSM, that is the Global System for Mobile Communication, and performance of the CGMA, that is the Code Division Multiple Access. On basis of all these things, you should know what actually NS2 and how actually the simulation takes place. Next, you should know what is network simulator and why is that the name NS2. So well, here as I said already previously, we know that we were in the state of learning with the NC2NS tool, where just the drag and drop concept was used. So in advance to that, now it's the time to know how actually one particular network traffic model can be built by using this simulation. So in order to know that, well, we have gone through the different series. So in order to analyze that, there is series NS1, NS2 and NS3. So accordingly, the NS1 is similar towards your NC2NS, where we are concentrating on NS2. So this is where this NS2 simulation, that is network simulation, will be implemented in the language of C++ and OTCL. So well, we have the simulation script and we have the simulation objects. So one will be playing as the backend, that is the C++, and the other end is the simulation object, which is called as the OTCL, that is the object oriented tool command language. So that will be following under the NS2 shell execution command, that is the NS. So what is this TCL and CL, which is bidirectional? So that's the concept we should analyze, where as I already said, we are going to deal with the TCL as the simulation script. But the thing is, we have two simulation objects. One is running in the back end and one is at the front end. So in order to connect the two C++ and the OTCL, we need the interference or the intermediate, which is called as the TCL, that is the tool command language class. So that will be acting as the intermediate between this particular, or it is the linkage that connects the simulation objects with the C++ and OTCL. So once it will be doing the required shell executable command, we should see the output files. So in which manner the output file will be given is all about the simulation trace files. So we will find out we will see the output of the required files in the form of a simulation trace file. So the trace files will be of two types. That is one is which is called as NAM, and one more is which is called as the xgraph. So with a particular to this particular file form, we will observe the required simulation trace files. So NAM is all about the network animation tool, and the xgraph where graphically we are going to find the required data sets and we are going to trace the files. So this is how actually the hardware architecture of the NS2 plays the role. So accordingly, we need to analyze how actually we are going to write the tool command language script, and accordingly how we are going to trace the file in order to observe the executable files. So next, you need to know what is the procedure to write the program of TCL and how to run, and what are the actual steps to be followed in each of the script components. So very first you are going to create the event scheduler. That is, what is the type? As I said, we may do the different network topology with the different transmission medium. So likewise, first we are going to create the event scheduler and required network. So before that, you need to create the network simulator object. So once the network simulator object is created, the thing is open the new file and turn on the tracing. Very first is you are going to create the file, and with the creating the file, you need to give the trace of all your files. So that we are using the option trace out all the program. And after that, you need to create the nodes. That is, in order to find the network traffic and in order to observe the packets, that is the data packets transmission that occurs between the different nodes. So in order to do that, we are going to create the nodes. And accordingly, the fourth one goes with the set up the links. So this link might be of your, already we know that it might be a simplex or it might be a half duplex and full duplex. So this is the types of links we are going to deal, and we are going to link the required setup of the nodes. So on the basis of the requirement. So usually we are going to preferably go with the simplex, or it might be also called as the full duplex. Okay. So accordingly, that is the way where it is going to work in the bidirectional. Where for an example are telecommunication. That is, we are going to form the two bidirectional transmission of data. So likewise, the fifth step is we are going to do the configuration, that is with the traffic type. So in order to do the traffic type, basically we are going to use the agents. So in your NS2 simulation, basically we are going to deal with the TCP and UDP. That is the transmission control protocol, and second one, that is the user datagram protocol. That is connection oriented as well as the connectionless oriented protocol. So TCP is the connection oriented protocol and UDP is the connectionless oriented protocol. So once the link is been connected, next we are going to attach the required UDP or TCP agent to the required nodes. For an example, we are considering the three nodes, N0, N1 and N2. So in order to give this particular thing, first you are going to open the new file and turn on all the traces and create the nodes. Once the nodes has been created. Next thing is we need to link it. Either it might be a duplex form or it might be a full duplex. So likewise, next is we need to configure the traffic type. So that we are going to attach the agent. Either it might be a TCP for the source. If you consider a node as the source and N2 as the destination, which we call as the sink. Okay. So likewise, we are going to attach the required agents to the required node of the trans. Then next is the set the time of traffic generation. So in order to check that, we are using the CBR, that is the constant bit rate, or it might be also the FTP, that is the file transfer protocol. So likewise, by using, why do we need to use this constant bit rate? That is called as the CBR, basically in order to analyze the behavior of the traffic that occurs in the networks. So in order to analyze that, we will be undergoing with the traffic generation. And finally, that's the process is the, once we start the any event, we need to stop it. So in order to do that, we are going to terminate the simulation. So likewise, all your NS2, that is the wired TCS script components, will be undergoing with this particular majorly 7 steps. So next one of the terminologies you should understand in the network simulation is all about the, we use the one of the term that is the flush trace, that is the variable flush trace will be used. Why? What's the use of this flush trace is, it's like it will dump the required traces into respective files. As I said, when you create the files, immediately you are going to trace all the contents of that particular program. So accordingly, with the help of this flush trace, what it is going to do is, it will dump the required traces of the files into respective files. So later, where we are going to trace the required packets in the particular programs. So one more thing is, as in C++, where we are going to deal the word global with respect to the inside the procedure where we are going to analyze. Whereas here, we are going to use the word global that is used to tell, that is, we are using the variables declared where the outside the procedure. Whereas in the C++, while writing the common program, we are going to deal the global declaration inside. So here, we are going to use the global as the outside the procedure. That's one of the difference you will observe while writing the tool command language. Once the execution of the files is being finished, you are going to observe the result. So how to trace the required output is the concept of NS2. Once we are easy to understand that particular tracing of the files, we will be able to explain what actually and how actually the simulation process has been gone under the computer network simulator. So in order to trace, when you open the trace files, so that we'll see with an explanation in the upcoming program. So in the trace files, you will observe the some of the symbols. That is the, it might be the plus or it might be the minus, and it will also show D and R. So very first you should know what are these terminologies and how to make use of this particular symbols and analyze the result. So accordingly, we are going to deal with the plus, that is the NQ, which is called as the packets arrival thing. So that's the plus, and minus is which is called as the DQ, which is the packets departure time. So accordingly, it will be given with a different field format, and accordingly that data will be stored. And we are going to analyze what actually how it's going through the all the N2, N1 and N2 nodes, and how the data packets transmission takes place between the three nodes, and we are going to find number of drop packets and number of packets received. So that is, the D is for drop and R is for receive. So what is this drop? That is the number of packets dropped in the required transmission of the data, and receive is nothing but that is the packets received at the destination. So likewise, tracing of the files will be analyzed with the AWK files, and with respect to that, we are going to use the required XGraph and NAP, that is the network animation tool. So with the help of these two files, we are going to trace the required network simulations in the NS2.